In this video, I will use the body of influence to refine the mesh in the zone where we have the mixing. And because of mixing, there will be the strong gradients of the temperature, velocity, and the pressure. And this zone will be approximately after the small inlet and maybe midway or before midway of this curvature. And for this to happen, we have to first define the one zone in the design molder, and this zone will now be merged with the mesh geometry. And secondly, we will go to Ansys meshing, and there we will define the body of influence like we do for the different sizing. And from there we put some size here, and that size be somehow the final size as compared to previous size on the volume basis. So let's do it. And for that to happen, I think that we should be using the, let's say, the fine mesh. And the geometry I'm going to use will be slightly different. So I will copy this geometry file. And also I will duplicate this this fine mesh file. And I will not create any connection between the geometry, this geometry and the mesh file here. And right now it is creating the container for the very fine mesh. And once this is done, I will create the link between the geometry and the mesh here. So place it over here, and I will rename the file, and this will be my body of influence geometry, and this is going to be my mesh for with the body of influence. So the fine mesh with body of influence, and create link between these two entities here. And double click here, the design molder will open, and I can add the body of influence in the design molder, and later on I will add this body of influence to define the mesh in Ansys meshing. So first of all, take a view on the let's say on the XY plane in this way. We click on the XY plane and then click on the locate, and after that I will open a new sketch. Click on new sketch, this is sketch number 9, and then from a sketching tab I will be making the few lines, and in such a way so that I can have the zone with the small inlet, some part here where the flow start to mix, and the some zone before the small inlet, so I can capture the flow before this mixing region. So LTI should be encompassing the region where I can fit the influence of mixing may travel back to that zone. So I will be creating line like this in this way. So it's not necessary to be a box here exactly. So this can be the combination of the multiple lines, let's say. So in this way, and make a line which is larger than the height of this mixing elbow here, and then up to here maybe. Not necessary to make the proper angles or proper lines or proper horizontal or vertical lines. So it should be a zone which should be larger than the zone of this geometry, so that when we apply the body of influence or body of refinement, it should refine the mesh. So it's even larger than the geometry, it will only refine the meshing inside the geometry here. So this should be enough to be not inside the geometry, but it should be outside geometry. So maybe you can make it up to here or maybe up to here, doesn't matter here. And then from molding tab, I will go to the extrude command, and this time again I will not stop up to the symmetry plane, but I will extend the geometry to the other side also. So maybe this time I will be using the let's say not the fixed one, in the direction basically it will be the both and the asymmetric. So both asymmetric means that on both sides I can have the different depth for my extrude command, but I can apply the different lengths or different dimension in the Z direction. So let's say here I put the length as a 4, so it will be somehow beyond will cross the asymmetric plane, but will be not excessively very large here. And it should also on this side should be larger than the geometry here. And also you should be adding the feature as edge frozen. So this geometry should not be uniting with the geometry of the elbow. Otherwise, we will not be able to define this geometry as a body of influence. So we have defined this geometry here, and now I will go to my meshing tab. Before that, I would be double clicking on the mesh here and close the mesh file which we have for this coarse mesh file, and close it, and double click on the mesh for this very fine mesh with that is a fine mesh with the body of influence. And now you can see that this geometry has been imported to this part here. But I can see one thing, that this is cutting my swan inlet over here. So I think I should extend geometry up to here, and maybe inclined over here, but it should be cutting geometry, or it should be extending up to the here. So I will go back to the design molder here and to the sketching mode again, and click on look at. And from sketching mode, I will delete the one curve here. So modify and the trim here, and then again go to draw, and from line I will use another line here in this way, and then make line from this point up to this point here. And you make sure that you should always be showing the symbol P here, which means that they are connecting with the points here. And now click on generate, and this should be okay with me now. So now I will double click on this mesh tab here, and then go back to you can see that in the geometry we have the two solids. One is a solid for the main geometry, which is this body of the elbow, and second is this body of this mixing elbow here. So you can see here, and also you can, if you want, you can display them in the wireframe as well. So here we have the option here in the wireframe. So you can see we have these two bodies. One is for our main geometry where meshing is done, and second is the body of influence, which will be used to only refine the mesh in this zone here. So I will click on the right click on the insert, and from here I will put the method. I will put the body of influence. And this can also be done from this sizing. So last time I told you that the sizing can be for the body, for face, can be for this edge, or maybe for the vertex. And same is true for the sizing. So either you go from the mesh insert and sizing, or you can click here and insert sizing here. The only thing is that if you want to apply sizing, so this time I will, instead of this element size, I would be using and I will select the body of influence, like over here, this one. So the geometry is my main geometry here. This is the body of influence. So the geometry where I want to refine the mesh, and this is the body of influence where I'm going to provide my zone where I can refine the mesh. And the element size you can define here, for example. So let's say your body sizing is 0.02. So you can first try with the 0.02, let's say, and click on the generate. And this will start to generate the mesh in this whole elbow, and including the refinement in the zone where we define this one by this red color. So now click on the mesh and also the solid view. So right now the mesh is almost same, because we have not changed the body of influence to some finer size. So let's say here I provide size as a 0.01. And you should be careful that they should not enhance the mesh numbers to the very high numbers, so that we will not be able to solve it in the Fluent. And it should be somehow maybe up to the 2 lakhs or maybe 2,50,000, not more than that. So because the fine mesh has a number of nodes around 1,12,000, like that. So this very fine mesh should be not more than the 2 lakhs here. And now you can see that we have the refined mesh, which is the cell size of the 0.01, and in the overall body of this elbow, the size is up to the 0.02. This is the maximum size which we can get here, and depending on the local condition, size might reduce to some lower value also. So here we limited the maximum size of the mesh in the domain in the whole volume up to the 0.01. So the size cannot go bigger than this value 0.01. So in this way we define the mesh. And now let me check the first quality. So you can see skewness is at the same value, which is around 0.83. And the another important thing, aspect ratio, which is right now is 234 which is in the boundary layer basically, especially on these zones where we have the first cell height is low and the cell size in the length is very large. And the most important aspect of the quality is the orthogonal quality, and its value is let me check. Its value is 0.04. Its value is 0.04. Its value is minimum is 0.04 and maximum is 0.99, and on the average is 0.83 and standard deviation is 0.115. So somehow we are getting the better quality because we refined the mesh, and this has also increased the orthogonal quality for which we defined for the coarse, medium and the fine mesh. It was reduced to the 0.027 for the fine mesh. But in the case of the very fine mesh, and we'll proceed with these all 4 meshes in the fluent section and compare them one by one and see that how results are changing with the mesh. And again I will reiterate that once the mesh size has been defined, results are not changing. So we will go for the mesh with the less size where the results are not changing much, and we call this one as a mesh independent